PowerPoint? Can you see my PowerPoint? Okay. So today we are revising chapter 9. Okay, and as we did yesterday, I'm not re-explaining the contents of the chapter. However, I am focusing on certain points with you that you need to make sure that you understand it very well. Okay. Now, chapter 9, we are using interfaces. You need to know the following. Number one, you need to know the benefits of using interfaces. Okay, so as we mentioned before, it helps for code reusing. It helps in decoupling classes. Okay, whatever I mentioned, if you don't understand it, just raise your hand by making a mark, okay, and ask me about it. So there are many benefits of using interfaces. If you go throughout your book chapter and your PowerPoint, you will find the benefits of using interfaces. Please make sure that you are able to list them. Okay, this is number one. Number two is interface implementation. How do you implement your interface? As we have seen in our Java programs that we have implemented. Give me a second, I will share with you my Eclipse editor. Okay. So as we have seen in week 1 programs that we have implemented together, here we go. How do we implement an interface? How do we use interfaces? Can you see my Eclipse? Can you see my Eclipse? Okay, perfect. We said that in order for any class to implement an interface, we use the keyword implements. This is very important. So public class bank account implements the name of the interface. All right. It's very important that you know that I can implement more than one interface. So a class can implement one or more interfaces. Okay, so if I want to implement a second interface, I will just make a comma here and write whatever interface I want. All right, so don't forget that, please. So this is about implementing interfaces, and how is the interface actually is defined. Here we go. I have, for instance, here something called measurable interface. So we go to the measurable interface. How do we define it? We just instead of the keyword class, we use the keyword interface, so public interface measurable. We open our brackets, and in this interface, we write our method signature. Again, we said that the interface provides me or defines which methods I need to use, but does not specify how these methods are implemented. So it gives me only the name of the method, what the input and the output of this method, what this method takes, and or what type it returns, but it doesn't give any body for this method. So no code, no implementation. Don't forget this, please. Okay, now a couple of notes when writing your interface. This is very important notes that you might be asked about in your exam. As you see here, the method, you write the output type, the method name, okay, and the brackets. In case this method takes an input, you will write the input here, for instance, int x, whatever, and that's it. Okay. So this is what we need to do, and then we write the semicolon, so no body implementation. All right? In this case, my method doesn't take any parameter. Now, a second thing that you need to note is that all methods in the all interface methods are automatically public. So whether I write the public keyword, okay, or I don't write it, by all means it is what? It is public. Okay, this is one thing. The second thing, all methods, since the methods in the interface provide no implementation, we call these methods abstract methods. So all methods in the interface are abstract. This keyword is very important, abstract. Okay, it's already mentioned here in your notes. And all methods are public by default. We have already mentioned that. Also, an interface does not have instance fields, so I cannot do something like that. Int x, you tell me this is an instance field. No, this is a problem. You see here, I cannot have instance fields. I cannot have what? I cannot have instance fields in interfaces. But can I have something like that? The only option, if I want to put some fields, I have to define it as static and final. In that case only, I will have, just a second here. Okay, and here, for instance, I will give it any value. So again, the rule is I cannot, interfaces do not have instance fields. What do I mean by instance fields? Because I cannot, of course, make an object or an instance of measurable. I cannot go here anywhere into the test class, for instance, and I cannot write measurable m equals new measurable. This is wrong. This is wrong. I cannot create an object of measurable. Interfaces cannot be instantiated. Okay, this means having instance variables doesn't also make sense. So interfaces do not have instance fields. The only option, if I define something like a variable, such a variable, it will be static and final. What does it mean? It means that this is not an instance field. This is a static, a class, or an interface variable. Okay, it belongs to the interface, and we cannot make instance of it. And why is it final? Because it has a constant value. Okay, and even if I put something like that, int x equals 5, by all means the interface will make it static and final. By all means, the interface will see this not as an instance field, but it will see it as a static final field. Okay, everyone's following? Everyone's following? Okay, so I will remove that now. And as I mentioned before, an interface cannot be instantiated. This is done. So please make sure that you know all these things. Now I go to my bank account class. If I want a class to implement my interface, as we agreed, we use the keyword implements. Once I use the keyword implements, I must give implementation to this interface method. So let's assume we have here one method. What if I have here another method that is called double, for instance, or whatever? Let's say public void print, and that's it. This is another method. So in that case, I have two methods here. If I go to the bank account class, then I must give implementation to these two methods. The first one is called get measure. Here we go. So in this one we have, it must be again the same signature. Public double, get measured, same name, no input, and then I'm giving the body implementation here. Note the following: if I remove the public here, I will have an error. Why? Because we said as automatically all interface methods are public by default, and if I'm now giving implementation, if I remove the public, this means I'm giving it a weaker access, because here the default modifier in classes is protected, so it's only accessible from any class within the same package. So in order to fix that, so it says here I cannot reduce the visibility of the inherited method. In order to fix that, we say here public. That's it. And since we have another method called print, we say again public void print, for instance, and I give the implementation. By the way, so far it's okay. I don't have to write code, by the way, here. As long as I have just written the method and give it a body, even if this body is empty, I'm okay here. Is that clear, everyone? Is that clear, everyone? Okay. Then I can continue now. Okay, casting between classes and interfaces. This is an important note. Casting between classes and interfaces. Here, we said, as we discussed yesterday, the casting between classes and superclasses and subclasses. There is also conversion between classes and interfaces. How do we do that? I will just go through this part here. Okay, now, rule number 1, I can easily convert from a class, okay, type to an interface type. I can easily convert from a class type to an interface type, given what? Given that this class implements this interface. So for instance, I have here measurable, which is my interface name, and so I have a variable here of type interface equals new bank account. So this means that I have a new object in the memory. It's of type bank account, and it is now converted to what? It is converted to type measurable. Is that okay? Yes, it is okay, as long as the bank account class implements the interface measurable. Okay. Same goes for coin. Coin also, I had here another class called coin. Okay. You see, I have an error here in coin because I haven't provided an implementation for the method print, which is in the method here. Get measure, I don't have one for the print. So I'll go now to my measurable class and just comment this part. Okay. So we go now to coin. Coin also implements the interface measurable. So I go now to the test class. Measurable M2 equals new coin. Again, okay, as long as coin implements the interface measurable. So the rule is I can always convert from a class to an interface type, given that this class implements this interface type. Is that clear, everyone? Is that clear, everyone? Okay, perfect. So I can continue now. Also, please make sure that you know the following. If now I have this example, measurable whatever mes equals new coin, so no problem. Okay. Now I need to call the method that is called get measure. Get measure is defined in the interface measurable. Okay, we have the signature for it, and the implementation for this method is provided in the coin class. So if I say now mes dot get what, it will see the get measure method, no problem. Okay, but if I want to say now mes dot get, for instance, the value, the method that's called value, I don't see it. Why? Now I do have already in the coin class, if you remember, we have the method that is called get value, and we have another method that's called get name. Okay, and the third method, which is the implementation of the interface I am implementing, it is the get measure. Now in my test class, if I go back again, we said that I can easily convert from a class to an interface type, given that this class implements the interface type. However, which methods can I call now if now I'm referring or I'm using a variable of type interface, and this one is referring to an object of type coin. Since it is of type measurable, okay, so I can only call the method that I can see from the point of view of the interface measurable. Which one? Which is the mes.get measure. But what if I want to call the get value or the get name, which are methods that are defined in the coin object or in the coin class? I cannot see them. Why? Because again, mes is of type measurable. Yes, it's true that it's referring to a coin object. However, still, it only sees the methods that it can access. All right? Is that clear, everyone? Is that clear, everyone? Is that clear, everyone? Okay, who has problem in that? Noor. Okay, Noor. Again, Noor. You see here, you remember you attended yesterday's session, right? Sahih Noor? For the superclasses and subclasses. You didn't. Okay. So let's explain it again. Okay. The thing here that I have an interface. In the interface, what methods do I have, Noor? I have only a method that is called getMeasure. Okay. And in the coin class, I have three methods: the getValue, the getName, and also the getMeasure. Why? Because it implements the type interface, the interface variable. Is that clear so far, Noor? But no need for this, doctor. I'm not following. I'm not following what you're saying. Just the methods. Which methods? Yes, I know. This question, the calling of the method, you mean, right? Okay, I'm not. Yes, I'm not explaining it again. I'm explaining the part that you are questioning. Okay. So again, if I go now to the test class, all right, we said that I have no problem in converting from a class to a type of interface, given that this class implements the interface. But note the following. Like this example, measurable mes equals new coin. So I have now a variable that is of type interface measurable, okay, and it's referring to an object of type coin. In other words, I have converted the coin object into a variable converted the coin object to an interface type which is called measurable. Okay, you see, this is what we're doing here. Now the question is, if I have now the variable that is called mes, and always remember, mes is of type what? Of type interface measurable. So can I call all methods the getMeasure, the getValue, the getName? No, I cannot. I can only call the method that I can invoke. I can only call the methods that I can invoke, which I can, or in other words, which are defined in my scope. So what is the measure that is defined in the scope of the interface? Only the getMeasure. Okay, but what if I want to call the getName? GetName is not in my scope. Actually, it is in the scope of what? Of the coin object. Okay, so I'm not a coin object. Again, no focus. I'm not a coin object. I'm an object of, or I'm not a variable of type coin. I'm a variable of type interface measurable. So I can only call the things that within my scope. But what if I want to now make the measurable interface, the mes variable, now be able to call the methods like getName and getValue? In that case, I will say, okay, please, mes, I need to convert you by force to a type, to a coin type. So how do we do that? Here we go. If I want to convert it by force, so now what am I doing? I'm doing the opposite thing. I'm converting from an interface to a class. I'm converting from an interface type to a class type. So mes here, I want to convert it to a coin, so I will use explicit casting called coin. Okay. This is will be stored where, or will be referenced here into a variable called mes coin of type coin. Now, if I want to call the getName method, mes.getCoin, here we go, no problem. If I want to call the getValue, mes.coin dot getValue, no problem. You see, I can see the getValue, the getName, the getMeasure. Why? Because now mes is of type coin, not of type interface anymore. Is that clear, Noor? Is that clear, Noor? Is that clear, everyone? Everyone? So the rule again, I can easily convert from a class to an interface, given that this class implements the interface. And if I want to convert from an interface type to a class, then I have to use here what? I have to use here casting. I think that's clear now, all right? Okay, then we can continue. An important information, please. What is the difference between casting numbers and casting classes and interfaces? All right. Now this is an important thing here. If I go to the class, what did I do here? I'm casting from coin, okay, from the type of interface to coin. Now make sure, please, when you do this casting, make sure, please, when you do this casting, that you are sure that actually mes.coin is that the class that you are casting to implements the interface. Again, make sure when you do this casting, then this class you are casting to is implementing the interface measurable. In order to avoid what? In order to avoid exception error. Okay. So as I told you here, if for instance I have something like this part, bank account, okay, which part? Now let's assume that I have something like that, mes, okay, bank account. Now you know that measurable or the variable mes was referring to an object of type coin, and when you reverse the conversion, you use the casting of coin. What if I do the same thing, but I'm using the casting of bank account? Here you go. So bank account mes2 equals cast mes to bank account. Now compilation error, you will not see any compilation error here. Why? Because you are there's no problem here. But when you run it, there will be a runtime exception. There will be an exception error. Why? Because in the beginning you had mes that is referring to an object of type coin, and then when you are now converting it or casting it, you are casting it to a type of bank account. So the Java runtime will be confused and will give you an exception error. Is that clear, everyone? Is that clear, everyone? So please, when you do the casting, you make sure that you are actually doing the right cast to the right object. Is that clear? Okay. Now, what if you cast numbers? So if I say something like that, double x equals, for instance, 2.5, okay, and then double y equals 2, that's it. And then I will say something like that, int z equals x over y. Okay. Now I will have here an error. Why? Because this is a double and this is a double, so a double over double, I must receive an output into z, which is of type int. So are you all following? Are you all following? Okay. So I'm dividing a double by double, so the output must be also double. I have to receive it in a value of type double. So it will show me something, an error here. So, but if I want by force to take the integer value of x, so I will do that, int x over int y. You see what I did here? I actually casted the x to int, so by force I made it an int, and the y by force I made it to int. Now, Will I see here any compile time error? No. Will I see any runtime error? No. But I will lose information. So instead of, for X, instead of having 2.5, I will have only now the 2. And for the Y, for instance, if it's 2.8, I will have also only the 2. Is that clear, everyone? So what is the difference now between casting numbers and casting objects? If you cast numbers, you have the risk of losing information. That's it. But you will have no runtime error or any compilation error. In the case of objects, if you cast objects wrongly, then you have a risk of what? Of runtime error. Again, no compilation error, but runtime error. The difference is clear? The difference is clear? The difference is clear? Okay, then we can continue. Muruj, I have just seen your Arabic message. I will read it afterwards. Okay, type. Then we can continue now. Okay. Inner classes. Inner classes is an important thing. Here we said in interfaces, sometimes the interface is very simple. So in other case, what we want to say that sometimes it is very insignificant. In that case, I will use it as an inner class of my original class. Like what? Did we have here any example? Okay. Right, I will actually, this means that I will go to the graphical user interface in order to, okay, so just wait for the inner classes. Before going to the inner classes, we need to revise the graphical user interfaces. Okay, but one point before going to the graphical user interfaces is the mock classes. The mock classes is already mentioned in your book and in your actually PowerPoint as well. Okay, what is a mock class? What is a mock class? Now imagine the following. Imagine that you have a very big project to implement. All right. So if you, for instance, if you have like the one mentioned in your example here, the grading book. Here we go. Okay. By the way, this is the thing that we have exchanged, Noor, and the one that you are confused about. Okay. So it depends on the type of variable, and from this type I can call which methods, right? Then I can continue here. Mock classes. Okay, now what is a mock object? Now the example here is that you had a grade book application. Okay, so you have a class called grading program. Okay, it manages the quiz scores using a class called grade book. So here it goes. Here we go. The class gradebook, it has the following methods: add score, get average score, save, etc. Okay. Now the problem is that sometimes you want to test your program without completely finishing it. So what shall we do? Well, in that case, we will do a simulated or a similar program to it, but that has less functionalities. Now imagine that the gradebook program is implementing an interface. Okay. Here we go. Now I have an interface called gradebook. Okay, this interface gradebook or iGradebook, whatever. All right, it has the following methods: add score, get average score, save, and all this stuff. All right. Now I know that my grading program, which is the actual class that I want to implement, must implement this interface and must provide implementation for all these methods. Now, if I want to make a similar program with less functionalities, or as we say, a prototype, then we call this as mock object. We call this as mock object. In that case, when we make our mock object, public class mock gradebook, okay, the mock object must also implement the same interface. Someone will tell you, but in that case, you must provide implementation for all methods. This means that you will completely finish the program. No, in that case, we will do the following. Although we are implementing the same interface implemented by, which is the iGradebook implemented by the original class, which is called grading program, when we provide implementation for the methods, we will only provide implementation for the methods that we need. So for instance, the get average score, I can calculate it. The get add score, I can calculate it. Okay. For the method that is save, I will just write the method name. Okay. And I will write here the body, and we'll leave it empty. Just make sure that you write the braces. So in order to show that as if you are providing implementation, but in fact you're not providing, you're doing nothing here. Okay, so to summarize, an interface should be implemented by both the real class and the mock class to guarantee that the mock class is accurately simulating the real class when used in the program. Okay, and why do we use the mock class from the first place? A mock class provides a simplified implementation of the services of the actual class. Is that clear, everyone? Is that clear, everyone? Where is the problem, Dalal? Okay, again, the last two. You mean the last two things I have said? Okay. All right, I will repeat it again. Just one small note. By the way, there is nothing called in Java library system mock or anything. This is just a way for or a hint for professional developers or programmers to, when writing their projects or developing their projects. So we use just the mock object whenever we have a big project that we want to implement and we just want to simplify it or implement part of it until we finish it. Okay, so what I have just said, I said the following, that a mock class in general provides a simplified implementation of the services of the actual class. That's it. And if you have an interface in your actual project, then the interface should be implemented by both the real class and the mock class. The real class, which is the actual project, and the mock class. Why do we implement the interface also in the mock class? To make sure or guarantee that the mock class accurately simulates the real class when you use it in the program. Okay? Are you following, Dalal? Okay, perfect. Okay, also the following. Now, we need to explain the graphical user interface. It's not actually a matter of explaining, just a matter of reminding you of the following. I will try to draw something very quickly here. Okay, it's important to know these three keywords: events, event sources, and event listeners. Events, event sources, and event listeners. And this is how it looks like actually. If I now draw this shape, now this is my event source. Okay, and I have another one called here event, and I have another one here called event listener. Okay, Now, the following happens. What is the event source in my, now when I'm talking about graphical user interface, this means that I can have a window with some controls on it, okay, buttons, menus, checkboxes, whatever. And whenever I make any movement inside this window, okay, something happens, an event happens, all right? Now, an important note, please make sure that you understand it. Who is handling or dealing with all these things? It's the Java Windowing Manager. The Java Window Manager. Okay? Now, I will explain here. Now, here we go. What are the possible event sources in my graphical user interface application button? So I can have event source means a control that generates an event. So a button can generate an event, a J checkbox can generate an event, right? A menu item can generate an event. Okay. What else? For the J panel can. What is a J panel? It's the frame of my application. But how can a J panel generate an event? If I'm moving the mouse inside the J panel, right and up and down, so I can here register some mouse events in my J panel. Okay. So all these are what? All these are possible. So any control can generate an event. Is that clear, everyone? Are you all following so far? Okay, perfect. Now, so this is the event source. Here we go. Now, what type of events can be generated in any application? Sorry. Okay. Many events actually. Now, in an application, for a button, I can have something called action event. So once a button is clicked, this is called an action event. Okay. Also the same for checkbox action event as well. Okay. Now for the panel, maybe it can be mouse events. By the way, I have several mouse events. Okay, move, mouse over, etc. Okay, here as well we can have another type of event. So again, in any application, I can generate many events, okay, that are generated from the event sources in the application or the controls in the application. So now we know two things. Now, who will tell me what shall we do or what shall happen once an event is generated? It is the event listener. So the event listener tells me what shall happen. Okay. Once, okay. You see here, key presses are also key press. If you press a key, okay, etc. Again. Who will tell me what shall happen once an event generates is the event listener. Okay. But what type of listeners do I have? For each type of event, again, make sure that you're focusing. For each type of event, I can have a listener which listens to when this event is occurring. Okay. Actually, it's not for each type of event. I can have a listener for one or more events, or I can have a listener for only one event. So, for the action event, for instance, I have an action listener, okay, and etc. For the mouse events, I have the mouse listener, etc. Is that clear, everyone? Is that clear, everyone? Okay. So the action listener. So what is now the flow? The flow is as follows. Okay, the flow is as follows. First, the user who's using the graphical user interface application is making an action. In other words, the user is, for instance, clicking a button. The user is moving a mouse in the J panel. The user is clicking a checkbox or scrolling the scroll bar. So all these are things that are done. Okay. So the events in that case, the event source that the user is dealing now with is generating an event. So this is the flow. The event source is generating an event. Here we go. Okay, no problem now. The event user is generating an event, all right? And once the event occurs, what will happen? The Java window manager will notify the program what to do. So again, so the Java window manager will notify my program, which is the code, what to do. How come? By going to the event listener. Now, what's the event listener? The event listener is actually an interface. So in order to register an event listener, what's the functionality of the event listener? The event listener listens for any event that might occur on any event source. So how can we define that? We define that by the following. I create a class, okay, that implements this event listener. So for instance, if a button is clicked, and I want to say that once this button is clicked, it will print a message called click me. So the button, this is event source. An event that is called action event is occurring, okay? So now who will listen to this event? The action listener, but the action listener is the interface type. So what shall I do with it? I will create a class as we did here in our program. Here we go. Here we go. My button, okay, and here we are. I have here created a button called click me, okay. Once this button is clicked, I need something to happen. So a message will be printed called I was clicked. So who's waiting? Who's listening to this event? The action listener event. But again, as I told you, the action listener is an interface. So what shall we do? I will go here and define a class. Well, just name it as you like. Public class click listener. Implements what? Implements the action listener. As we agreed before, each interface has a message, okay? So that each interface has a message for which I need to provide implementation. So the message signature for the action listener interface is called action performed. So in my case here, I will provide implementation for the action performed method. So I will public void action performed. It takes an event of type action event, okay? As I have shown you here, the event is called action event, all right? Now, I will provide the body, and in the body here, I will print I was clicked. So again, what will happen? What will happen again here? We go to the PowerPoint. So now the button is clicked, and an action event is generated. A listener will listen to this event. How do I use this listener? By implementing it. So I'm implementing the action listener on a class called listener, and I am providing the code of what shall happen once this button is clicked. Are we clear, everyone? Are we clear, everyone? Okay, perfect. But one important step is missing here. Who said that this event listener, okay, or action listener is waiting for this button? Someone has to say that this listener is listening to any events that is occurring on this button. So don't forget this line here. I need someone, okay, like that one. Just a second. I will use another shape. Here we go. No problem, just whatever shape, because I don't want to waste time here. Okay, another one. So I think it's just an arrow that is directing from the event listener here to this event source. Okay. Here we go. And this is called what? I need to register the event listener that for which I have provided implementation now to the event source. So now, what shall I do here? I need to register my event listener. How do we do that? Okay, so this means that I'm register listener. How do we do that? By going to my code here and going back to the class which is called, on which I have defined my button. And here we go. In order to use the listener, to use my click listener, I will create an object called listener1. In this case, it's of type what? It's of type action listener. Okay, and no problem, as we said, we can easily convert from a class object to an interface type, given that this class implements this interface. Then, most important, I need to add the listener to the button. So btn, which is the object of my button, dot add action listener. Which listener are you adding now? I'm adding listener 1, which is the object here called listener 1. So the steps are as follows. Make sure that you have your event sources. Make sure what events you need to listen to. So create the class that implements the listener. Okay. Then make an object of the class listener that you have implemented and add it to or register it to the event source. Is that clear, everyone? Is that clear, everyone? Okay. Now note the following, please. An event source like a button can have more than one listener listening to it. So I can have more than one event generated by this button, and I can have more than one listener listening to this event, or I can have only one listener registered for the button, okay, and it implements all actions, like we did here in my code example. I said once I click the button, I want two things to happen: a message called hello and a message called to be printed, and a message called I was clicked, as we did it here. Here, click me. Once I click the button, click me, it will print hello and I was clicked. In that case, I have two options. Either I print another message called here system.outPrintLine hello, or I make another listener. Okay? How do we do that? I created another listener. But in my case here, I created this listener or this class as an inner class. Now we go to define now what is inner class. Here we go. In my button viewer. Now, when do you use inner classes? Again, the same concept is the same. Class my listener implements the action listener. It provides implementation to the action performed, so system.out.println hello. And then I created an object of my listener. Here we go, action listener 2. And then I added the listener again to the same button. Okay? Now, the question is, in the first case, I use it as a separate class called click listener. In the second case, I use it as an inner class. Now, when do we use inner classes? Inner classes, we use it whenever the class is very trivial or small or insignificant. So all what we need, it's about only 2 lines. So we can simply reduce the files that we are generating and put it as an inner class of my class. And we put it as just an inner class of my class. Is that clear, everyone? Is that clear, everyone? Okay. Now, in my case here, okay, perfect. Just need to, okay, I think I need to stop now, right away, because I have a session. Okay, now make sure that you know the following, please, concerning inner classes. The methods of an inner class can access variables declared in the enclosing scope. So an inner class can access any variable that is declared in the enclosing scope. Okay? And an inner class can only access local variables from the enclosing scope if they are declared as public. Again, these things I cannot discuss now, or because I have to stop. We have already started very late because I have a session now. I don't know how you will. There are a couple of points that we need to revise regarding this chapter 9, and then chapter 10. So please tell me if you have some time tomorrow, or maybe we can do another session today after session. Okay. Because we already have started it. We started very late today. So, Dalal or whoever, Muruj, please send me an email, okay, of when you want to complete the revision. Because we're already now out of time. I will stop recording.